Kia ora tātou, welcome. We're parking the big news item of the evening, and we'll have a look in a couple of hours and see what's happening, but it's still undecided, so it may stay that way for a while. But an even bigger news item, if it can be bigger than Donald, is climate change. And climate change is coming upon us. I've just been travelling actually, and I've been in Italy, in Bologna, and I was there at a time of huge flooding. And then I was in the south of Spain and left it about a week before the catastrophic floods that have just killed a lot of people in the south of Spain and shocked the whole country. So it's a big issue, and I'm delighted tonight to welcome Professor James Renwick, who's a climate scientist who has authored 3 IPCC reports, co-authored 3. He's won the Prime Minister's Award for Science Communication. And what else have I got? He served on our Climate Commission, so he comes with a whole list of achievements. So I'm going to hand over to James to outline what's happening, what's going on, how do we can we reach a tipping point? Will the politicians ever decide it's time to do something? Okay, James.
Great question. And thanks very much, Philip, and thanks everyone for coming. Kia ora tātou. I'm going to talk about what's some of the latest on climate change. Can everyone hear me okay? Yeah? Okay, great. And what do we do about it? So the picture on the title slide was taken in Dunedin a few weeks ago. The big floods down there, South Dunedin, which was a bit of a problem area, one of the most problematic areas in the country because the water table there is so high. When it rains, water doesn't drain away very easily, and as rains get heavier, you get these situations happening more often, which must be pretty disconcerting for the people who live down there. Okay, so what's happening? This is a graph of average temperatures up to last year. So the little dots and the jerky line is each individual year, and the red line is a smooth version, basically the sort of background trend, if you like, minus the ups and downs one year to the next. And you can see this is from the Berkeley Earth data set in the US. You can see that there's been getting on for 1.5 degrees of warming. The last annual value in 2023 was above 1.5 degrees above, well, not exactly pre-industrial, the average temperature between 1850 and 1900, which is about as close as we can get to what temperatures were in the pre-industrial period in the 1700s. So with this data set, it's saying we've gone through 1.5 degrees above pre-industrial last year, but the red line is maybe a more important one to look at, and that's still down below 1.4 degrees, maybe 1.3 something. So it's been warming up pretty rapidly lately. And if we look at what's been happening just in the last few months, this is now from the Climate Reanalyzer website. This is data from Europe, and it's an average over the globe. This is on a daily basis now, so this is the annual cycle from January to December. Each line is a year, and the sort of light orange lines last year, and the darker red line is this year. So you can see last year it was warm all year, but then about the middle of last year, the temperatures really started to go above anything that had been observed before, and they stayed well above the mass of other years right through the rest of the year. And then this year has essentially followed the same pattern. And in the last few weeks, this is to the end of last month, temperatures have been at least equivalent to what we saw this time last year. So maybe 2024 will come in as a new record warm year, but it's certainly going to be one of the top handful if it's not quite a new record. So again, things are warming up pretty dramatically. And I've just realised, I'm thinking, what's the next slide got on? I didn't get my notes out. That's not very helpful. So just hold that thought for a sec. I think I know what's on the next slide, but it's always good to have a verification of that sort of thing. Here we go. Yeah, okay, yeah, all right, all set now. So, I guess the question I've heard it put often is, have we exceeded this 1.5 degree threshold, which is the bottom of the Paris Agreement range? You know, the Paris Agreement said the world would do what it had to do to stop global warming at well less than 2 degrees above pre-industrial, and would pursue efforts to stop it at 1.5. So that 1.5 to 2 degrees of warming was considered at the time to be, in some sense, a sort of safe region. If we got above 2 degrees, things started to get a bit uglier. It became harder to deal with the impacts. So have we exceeded that threshold? Well, I'd say not quite. That red line is still below 1.5 degrees, but we have had 1 year at least which has been at least grazing the 1.5 degree threshold. We really need several years above 1.5 degrees above pre-industrial to say that we've broken through that limit. So not quite, but it's obvious that, you know, we're very, very close. We are very close. So plenty of evidence of climate change around. You know, you've already heard mention of what's been happening recently in Spain, and there's been big floods in parts of Africa and Southeast Asia, and events here in the recent months and years. So it's obvious stuff's happening. But the world doesn't really seem to be doing anything about it. This is a graph of annual emissions of carbon dioxide. And carbon dioxide's the big problem because it stays in the atmosphere for a very long time. It builds up. And it's the greenhouse gas that we emit, which is there in the highest quantity. So it's the big one to worry about. And you can see this graph goes back to the Intergovernmental Panel's definition of when the Industrial Revolution started in 1750 and goes through to last year. So you can see that the total emissions, which are now above 35 billion tonnes per year, weren't doing much until about the middle of the 19th century, and then really started to ramp up, and it's been an almost exponential growth in emissions in the last century or so. The COVID lockdowns are this little blip here, and when this happened, there was about a 7% reduction in global emissions. And a lot of people, myself included, said, gee, if we can just do that every year from here without the pandemic, problem solved in a few years. But of course, things have bounced back, and we now have numbers that are just a little bit higher than they were before the pandemic happened. So again, there's not a lot of sign of any action being taken. Oh, and this graphic is from the Our World in Data website at Oxford University. Really neat place to go and look for all sorts of information. So the Rio Summit, which founded the United Nations Framework Convention on Climate Change, happened in 1992, and global emissions were 22 or 23 billion tonnes per year then. The Paris Agreement was signed or written in 2015, signed in 2016. Global emissions were above 35 billion tonnes per year by then. And there have been 6 reports from the Intergovernmental Panel on Climate Change in this time, 1990 through to 2021, 2022, the latest one. So, you know, the policy makers and the business leaders, the people who really have their hands on the levers of how our economies work and so on, have been very well briefed on this problem. They've known about it for decades, but still, there doesn't seem to be much in the way of action. In fact, you can say that half of the total human emissions of carbon dioxide since 1750, the nominal start of the Industrial Revolution, have been emitted in the last 30 years. So just the arithmetic of how quickly this curve has gone up. Well, another way I've heard it put a few times is that roughly half of the human emissions have occurred in Taylor Swift's lifetime. And in fact, half of those emissions have occurred since she released her first album. So I'm not trying to diss Taylor Swift. It's not her, well, you know, she flies in a jet and all the rest of it, but it's not her problem particularly. But she's been alive for the really steep part of this curve here. So because this stuff stays in the air for such a long time, it does just collect, it builds up. So when you look at the total amount in the atmosphere, you get a graph that looks like this. So now, instead of going back to 1750, which is back here, is here somewhere, we're going back to about 11,000 BC. So the last 13,000 years or so. So coming out of the last ice age, carbon dioxide levels were rising up gradually, got up to this 280 parts per million, bouncing around. This is the so-called pre-industrial level. And then we started burning coal and then oil and gas, and all the stuff started building up in the atmosphere, and we're now up to about 420 parts per million, which is a 50% rise on that pre-industrial level. So how difficult climate change impacts become purely depends on how much higher this spike's going to get. And that depends on how quickly we can reduce emissions from here. And like I was saying, there's no sign really, apart from the pandemic, that anything much is happening on that front. In fact, the United Nations, oh boy, how did that happen? What am I doing here? Go back. Back one more. Hey, there we go. Yeah. Oh, you've seen most of the talk now. I can sit down in a sec. So the United Nations Environment Programme put out what's called an emissions gap report every year. And the one they released last year, they just called Broken Record. They said, yet again, nothing's happened, essentially. So I suppose the idea that the global geopolitical sphere are not really taking any action is very well known. So when the last IPCC assessment report came out, one of the slide packs that was made available for that had this black slide, the warning that the pace and scale of climate action are insufficient, which is an understatement, to tackle climate change. And Antonio Guterres, the UN Secretary General, had a number of things to say about this. He called it Code Red for humanity. And I was quite taken with this comment that current policies are taking us to about a 2.8 degree temperature rise by the end of the century. This spells catastrophe. Yet the collective response remains pitiful, and this is something I don't understand. We face these big hazards, these big risks, but the response just is not there. Now, that IPCC report had a number of headline statements. This is one that I think is really important. It's indisputable that human activities are causing this to happen. And the way we feel this is through these extreme events. So heat waves, heavy rainfall, the opposite, droughts. These are all becoming more frequent and more severe, and those are the things that do the damage to our lives and to our infrastructure. So again, how high that spike in the graph of carbon dioxide gets determines how bad these events become and how manageable or otherwise they are. So just to get a wee bit techie for a bit to talk about these extreme events and how it all works. This is a schematic drawn by my colleague Andy Reisinger of temperature variability. So the idea here is we have a bell curve, a Gaussian distribution, this shape here, where the average temperature is the peak of this curve. So the height of the curve is the probability of occurrence. So the most common temperatures are around the average temperature. And then you've got very cold events over on the left-hand side and very warm events over on the right-hand side. And warming the climate means we're shifting that distribution to the right, to the warm side. So you might move the mean temperature not very much. You're still well within the sort of normal range here. Temperatures have gone up 1.3, 1.4 degrees. It doesn't actually sound like much. But the point is, you've got some threshold of hot days, hot years here. As you move this distribution, the area under the curve, which is how often these things occur, increases really rapidly, much faster than you might expect from just what you hear about 1 degree of warming or so on. And at the other end of the scale, the cold events, the frosts might disappear completely, and that's certainly something that's ongoing around the world. In New Zealand, we've seen a decrease of about 50% in the occurrence of frost in a lot of places in the country through the 1 and a bit degrees of warming we've had here. So you increase the average a small amount, and you get a big increase in the chance of warm extremes, of hot days, hot events, including some unprecedented values that just haven't been recorded before. And we certainly, I don't know if this is such a big deal in New Zealand, but in some parts of the world we're seeing record high temperatures that have not been recorded before, remembering that the recorded history of climate in some parts of the world is pretty short. It might only be 50 years, maybe it's 100 years, and in one or two places there are records going back maybe 300 years or more, but they're very, very rare. So we don't have a hugely long record of temperatures to say just how uncommon some of these very hot extremes are. So that's temperature. It's relatively straightforward. And what we see for New Zealand, and this graphic is getting a bit old now. It's from information put out by NIWA a few years ago. The latest version has come out. MFE provide it on their website. I just couldn't find a picture that was quite as nice, so I'm using the old one. So this is for a sort of middle of the road scenario with maybe 2.5 degrees of global warming, and you can see the colour, the temperature rise over New Zealand. It's a pretty bland pattern, a little bit less down in the south, the area that's closest to the southern oceans, which are warming up pretty slowly, and a little bit more up in the north. But we're talking about sort of 2 degrees or a bit above that over the whole country. And that goes along, round numbers, roughly speaking, with a tripling of the number of hot days with that amount of warming. In Wellington that might be above 25 degrees, and in Invercargill it might be above 20 degrees and so on, but whatever the number is you choose, you get roughly a tripling of the number of hot days with that sort of warming. And it's a fairly straightforward calculation. For rainfall, it's more complicated. And rainfall is not, temperature is just sort of a smooth kind of distribution. Rainfall is really lumpy. And in fact, there was a publication a few years ago that amazed me and a lot of people. They calculated, well, how many days of rainfall do you need to get half of the annual total rainfall in this place, whatever stations they're looking at, and then they averaged that over the whole globe, and found on average you get half your total annual rainfall in 12 wet days. Get 12 dumps of rain and that gives you half of your annual total. It's a little bit more for New Zealand. I did this calculation for a few New Zealand stations and it's more like 15 days or 16. It's not 100. We're talking about a couple of weeks where it really hoses down and that gives you half of your total rain for the year. Then the idea is that as the climate warms, you get more moisture in the air, so you get that half your annual rainfall on fewer days. So you might have 11 days or 10 days in the future where you're really going to get hammered with rainfall. And this is because the amount of moisture in the air increases with the temperature. So you see more heavy rainfalls, more floods, more frequent floods, and floods that are bigger than have been seen before in some places. Then the flip side of that is, in a warmer climate, evaporation works better. So moisture gets sucked out of the soil, sucked out of plants more quickly, so droughts can develop faster in a warmer climate and you can get dry spells setting in really quickly. People talk about flash droughts these days. And once they've set in, there are feedback mechanisms that allow them to continue, so you get sort of dry spells that can tend to last longer. So you get extremes at both ends of the scale. And days of moderate rain are getting squeezed out. So you're getting heavier rain when it falls, but you're getting longer dry spells and more droughts in between those. So you're seeing more variability in rainfall. It's not just a straight shift of distribution to the right kind of situation. And a colleague of mine at Waikato University, Luke Harrington, published a very nice paper on this that came out this year. It's a bit of a, scientific looking diagram. This is a map of New Zealand, obviously, with sort of climate model scale grid boxes shown on here. So what this is showing is for this very large group of climate model results, if you have a 3-degree warming compared to pre-industrial, the colours show the percentage of rainfall averaged over the year that you would experience for a 3-degree warming. And the grey colour is basically, it's 100%, so no change in rainfall. The brownie colours are where it gets a bit drier, down to maybe 95%, and the blue colours on the west coast of the South Island where it gets a bit wetter, maybe 105%. So we're seeing a few percent either side of no change. And for most of the North Island, it is no change. The average rainfall doesn't really change for this 3 degrees of warming. But when you look at the extremes, you find that pattern I've talked about before. So what we've got here, just look at the top row. For that 3 degrees of warming, you take the top 1 percentile, the 1% of days where it rains a lot, and how much does that change? And you see, again, this colour scale is right down the bottom. I don't know if you can see it, but the blue colours are something like a 10, 12, 14% increase in rain on the really wet days. And then on the right, for the very dry days, the dry periods, you see these colours, the browns are sort of 90%, 86, 88%. So we see something like a 10% increase in the wetness on the wet days and a 10% decrease in the dryness on the dry days. And this is for places like most of the North Island where the average doesn't change at all. But the variability goes up, and you have to cope with these really big dumps of rain when it rains, and then have the water supplies to get through the dry periods. So big implications for water storage and water management, essentially. And I think for this country, this is the effect that we feel the most. The temperature extremes, well, New Zealand's a pretty temperate place. It will have to get a lot warmer before we really start melting down, but dealing with these rainfall extremes, that's, I think, the hard part for us. And as we've already said a few times, here's a couple of pictures from the Valencia region in Spain, where they had this amazing dump of rain in the space of essentially a day. Motorways and infrastructure all over the place, really damaged. These pictures are from the Guardian website. Yeah, and you see, this is not the first time I've seen pictures like this. I've seen a number of these sort of events, especially in Europe and maybe Southeast Asia, where there's a lot of vehicles and things just get trashed. I haven't had to deal with this, but I don't know what it feels like. It must be absolutely devastating. So what happened here is these places on the east coast of Spain got something like a half a metre of rain in a matter of a few hours. And these are some of these places that only get half a metre of rain in a year. Normally they got it in a day. Now, half a metre of rain is quite a lot. Even on the west coast of the South Island of New Zealand, you wouldn't get that very often. It does happen, but it's pretty rare. But those are places where the average rain for the year is in the metres. For a place that has as much rainfall as you typically get in Christchurch or maybe Napier, to get that much rain in that short a time, they just would not have been prepared for that. So, we know that there have been big rain dumps in places like Valencia before, but the way the climate's changing and adding this moisture to the air, they're just becoming worse all the time. So the chances of this kind of thing happening are increasing as we go on with warming. Okay, back to this country. Like I've already said, a 2-degree warming equates to roughly a tripling of the number of hot days wherever you are in the country. And for places that are drying out, which is mostly the east coast of the South Island and maybe parts of the east and North Island, 5 to 10% less rain with warming, you get roughly a tripling of the occurrence of droughts. Put those things together, and again for the places that are drying out, you can see roughly a tripling of the length of time in the year where you're in either extreme or very high fire danger. So the chances of getting fires like this one's a picture of the fire on the Port Hills a few years ago near Christchurch, the chances of those going up all the time. I'm not saying that there will be more fires, but the conditions to allow big fires to happen are becoming more prevalent all the time. And then there's sea level rise. So I'm not going to say an awful lot about sea level rise. This is a picture of a road in South Canterbury that was eaten away a few years ago, just to make the point that as the sea level goes up, these sort of events will happen more easily, they'll happen more often, they'll happen in more places, because as you raise the sea level, when there's a storm, the waves have an easier job to come on shore and come inland, and they'll eat away at whatever's there, unless it's a particularly rugged, rocky coast, which this wasn't. So some numbers, we're expecting it's essentially baked in already. We'll get 30 centimetres more sea level rise in the next 40 odd years, and we've had 20 centimetres around the coast in the last 100 years. So much faster rise in sea level now than we've had over the last century. How much we get by the end of the century and beyond, that really depends on what we do with reducing emissions, if we reduce them. But somewhere between 0.5 metre, that's the bottom line, that's guaranteed. And it could be 1.5 metres, could possibly even be a bit more by the end of the century or shortly beyond that. So, like I was saying, as sea levels rise, we just get more of these events in more places. And because beaches, coastlines are pretty flat, a small rise in sea level translates to a long distance movement in the high tide mark, and that's what's really important. This road was several metres above sea level. It still is, what's left of it, but it was very close to the high tide mark. So as you raise the sea levels and you get a storm which raises sea levels episodically much more, you get those waves coming in, and they're just going to deal to whatever's in the way. So the Parliamentary Commissioner for the Environment published a report, this is 10 years ago now, looking at the chances of coastal inundation events and how those chances change as you raise sea levels. So for Wellington, and again these are fairly round numbers, but for 0 centimetres of sea level rise you get one of these, the event they're looking at once every 100 years. By the time you've had 0.5 metre of sea level rise, this is happening every couple of weeks. So it's incredible how quickly these sort of coastal inundation events change as you raise sea levels. And 50 centimetres, that's guaranteed this century. We cannot stop that from happening now. So we're going to be in for a lot more damage to infrastructure around the coast in Wellington and pretty much everywhere. So this is the subject of lots of reports in the media, and I think the insurance sector are totally onto this, and there are already places in the country where you cannot get coastal flooding insurance for homes, and it's going. I think this so-called from the coast could be largely driven by the insurance sector, and whether it's or not remains to be seen, and it varies from one part of the country to the makes me think of this diagram here. This is from the IPCC reports. Various versions of this have appeared many times in these reports. The so-called propeller diagram. I'll just quickly explain what I'm talking about here. The risk that we face, whether this is from coastal erosion or flooding or whatever, depends not just on the hazard. So you've got the climatic or weather event, the big rainstorm or so on, and they are changing because of climate change. But how much risk you're exposed to depends on your vulnerability to that event and to your exposure. If your house is right on the beach, well, you're pretty exposed to coastal inundation. So you can actually reduce your risk and reduce the impacts by taking some kind of action, adaptation and mitigation action, to get you away from this hazard. So it's not as though we're just doomed to face these problems and we have nothing we can do. We can do a lot of things, just getting out of the way of the harm, essentially. But it's easy to say that. It's not necessarily so easy. Yeah, I've done it again, haven't I? Control yourself. Yeah, there we go. So these are all the ocean parts of the story, and they are more than 90% of the total increase in energy in the climate system. The atmosphere part, the warming we've experienced is this purple bit, and you can hardly make it out right down the bottom of the graph. It's about 1% of the total. If all of this heating had gone into the atmosphere, temperatures would already have gone up about 40 degrees. We'd all be dead. So it's good news for us that the oceans are doing this job. They're absorbing most of the heat. But the other side of that is that oceans take a long time to respond. And so we've locked in some form of climate change for centuries into the future, just because we've pumped so much heat into the oceans. And of course, one thing that happens when you heat water is it expands. So the column of water in the ocean is getting deeper because it's getting warmer. So that's one of the main reasons we get sea level rise. So again, we've locked in a certain amount of sea level rise for a long time into the future. How fast sea levels rise from here totally depends on what we do with emissions, but we will get sea level rise for centuries into the future, pretty much regardless of what we do. Now, the other components that are contributing to sea level rise, heaps. Yeah, yeah, the vertical scale, that's right. These numbers, so 400 ZJ, zettajoules. Now, a joule is a pretty small amount of energy, but zeta is 10 to the power of 21. So we're talking about 4 with 23 zeros after it. Lots and lots and lots of joules, huge amounts of energy. So something like 1,000 years of annual human energy use at the moment. It's an unimaginable amount of energy has gone into the oceans, or gone into the climate system, I should say, in the last 50 or 60 years or so. So it'll take a long time for that to work through the system. So the other things that are adding to sea level rise are ice melt. So we're putting more water into the oceans as well as expanding the water that's already there. So this is from the World Glacier Monitoring Service in Switzerland. They monitor hundreds of glaciers around the world and make an estimate of how much mass change there is from year to year in these glaciers. And this goes back to the 1940s through to a year or two ago. And you can see the story here, it's going down. So the amount of ice in glaciers is decreasing and has been decreasing for several decades, as long as we've been monitoring these things essentially. And you can see that the slope of this line, it's not just a straight line, it's started to melt. These glaciers have been melting faster more recently as temperatures have gone up, as we've added greenhouse gases faster and faster to the atmosphere basically. And New Zealand's no stranger to this. Here's the Tasman Glacier in the Southern Alps. There's the snout of the glacier here, and there's a big proglacial lake at the end of it now, which has been around for 30 odd years or so. And once you get one of these lakes forming, that helps to melt the ice faster. So we've been losing ice mass in the Southern Alps in New Zealand at a similar rate to the rest of the world, basically. And that water ultimately flows into the sea and adds to sea levels. And the other thing to do with sea levels, the thing that you hear about the most probably, is the big ice sheets. So the ice sheets in Antarctica and Greenland are both melting, and this is a pretty short time series. It's a satellite record that goes back to 2002, so it's just over 20 years long. And you can see on the plot on the left, that's Antarctica. This is decreased down to this point here, and the vertical scale here is gigatons, so billions of tons of ice, and each of the ticks is 1,000 gigatons. So each of the ticks on the vertical scale is 1 trillion tons of ice. So Antarctica's lost about 2.5 trillion tons of ice in that 20-odd year period. Greenland, which is much further from the pole than the Antarctic ice sheets, has lost about twice that much, about 5.5 trillion tons from 2002 to this year. So between them, we've lost maybe 8 trillion tons of ice from the ice sheets. And there's a little exchange rate at the bottom, if you can see it. You melt 360 gigatons of ice, spread that water out over the global oceans, and you get a layer that's 1 millimetre thick. So even this mind-boggling number, 7 or 8 trillion tons of ice, translates to about 20 millimetres, a couple of centimetres added to sea level because of this ice sheet melt. That, again, it's one of those numbers that doesn't sound too frightening, but there's a lot of ice in these ice sheets. If all of the Greenland ice sheet melted, we'd be adding 5 metres to global sea levels, and if all of the Antarctic ice sheet melted, we'd be adding 10 times that much, over 50 metres to global sea levels. But they're big pieces of ice. They don't melt overnight, over a weekend. They would take centuries, thousands of years actually, for the East Antarctic ice sheet to melt completely. But if we push the climate system hard enough, we can lock some of that in. We can pass a threshold where the West Antarctic ice sheet, at least, which would add 3 or 4 metres to global sea levels, might get to an irreversible melting state. Some people claim that this has already happened, but I think the consensus is we're not quite there yet, but we're getting close. So, looking at actual sea levels, here's a graphic from a paper that was published a couple of years ago, going back to the early 90s. So again, this is satellite record, and it's a pretty short period, 30 years, and sea level on the vertical scale here. And this 30-year period was divided into 3 10-year periods by these authors, and they just fitted some straight lines. So it's a short time series. I'm not claiming this is the perfect answer, but it illustrates the point that sea level like the melt of the glaciers and so on, it's not a straight line. The slope on this curve's gone up. So in the first 10 years, we're talking about 2.25 millimetres per year. In the last 10 years, we're talking about 4 2/3 millimetres. So roughly a doubling in that 30-year period of the rate of sea level rise, and the average for the 30-year period about a bit over 3 millimetres per year. So again, I'm not trying to extrapolate this into the future too much, but just to make the point that as we add water to the oceans faster and as we heat the oceans more rapidly, we get faster sea level rise. How are we going for time? Oh, yeah, okay. All right. Hello, what's going on here? I haven't accidentally switched this off, have I? Huh, interesting. Oh, yeah, yeah, you could always do that, couldn't you? Use your finger. Yeah, there we go. Hopefully I don't have to do that once. So another thing to take account of, and again, this has been in the media a lot in this country, the Sea Rise program based at Victoria University and GNS, looking at vertical land movement around the country and how that interacts with the way sea levels are rising. And this graph, which you can get off the Sea Rise website, shows how much land movement there is around the coast, around the whole country. And there are some places, the vertical land movement scale is on the right here. The brown colours are where land's going up. And there are some places where that's happening, such as in the Bay of Plenty, Fiordland, and pretty much all of Rakiura, Stewart Islands, rising. Great stuff. But the rest of the country is going downwards. And around Wellington, we're talking about 3 or 4 millimetres per year, which is roughly the same as the rate of rising sea levels. So it's really adding to the local change in sea level, this dynamic change in the land itself. And hey, that worked. So what you can do on this website is, just click somewhere, such as the Kapiti Coast, where I live, and you get a graph showing what's going on and what the expectation is. And you can see, there's quite a bit of uncertainty. The shading here shows as you go out into the future, it becomes quite uncertain how quickly sea levels will rise, what's happening with these thresholds with the West Antarctic and so on. But the average, you can see, so we've got vertical change in sea level on the vertical scale here, and this is going from the year 2000 to 2150. So just the sea level rise itself is the dashed line, and this is for a sort of middle of the road scenario, SSP 2 4.5, if you know what that means. It's sort of not big reductions in emissions, but not big increases either. And I've included vertical land movement, and that gives you the solid line. So just to illustrate the point, if you choose a threshold, and I'll just go back to the computer, I think. So 60 centimetres of sea level rise, a bit above that guaranteed 1/2 metre. It just fit it on the graph nicely. And if you drop down to looking at the dashed line where you've just got the sea level rise, that might occur on, the average estimate would be about 2107, or between 2100 and 2110. But when you add in the vertical land movement for that location, that brings it back to before 2100. So it brings the timing of this rise in sea level back 15 years or so. And in some parts of the country, we're talking about twice that sort of different, 30 years earlier. So it's a really big deal if you're thinking about protecting infrastructure by the coast. How quickly are you going to have to respond because of this movement in the land? It's not peculiar just in New Zealand, but it's certainly an issue in this country because we're so tectonically active here. Oh, hey. All right. Tipping points, something else you read about quite a bit in the media, or at least I do. And now it's stopped working again. Maybe I'll just... Oh, yeah, go on, James. Yeah, good man. Thank you. Yeah, there we go. So the three that I think about most often are the loss of the West Antarctic ice sheet, loss of the Amazon rainforest, and the shutdown of the deep ocean circulation, the sort of day after tomorrow scenario. And yeah, Thanks, James. It's hard to pin down exactly where the thresholds are for these things, but what we know is they all become more likely to happen as temperatures rise. The West Antarctic ice sheet, from the geological record, we know that if we get to 2 degrees of warming or a bit more than that, it's pretty much guaranteed we'll lose the West Antarctic ice sheet. Again, it would take a long time to melt, but we couldn't stop it once it started to melt irreversibly. So we're getting close to the thresholds for some of these pretty important things. Next slide. So yeah, what do we need to do? Finally getting on to the response to all this. Well, here's a graphic from the IPCC again, and a bit techie, but time along the bottom from 2000 to 2100, and the vertical scale is the annual emissions of greenhouse gases. This is greenhouse gas equivalents, so it includes methane and everything, so the numbers are a bit higher. So you can see that, you know, the emissions have been going up, and all the policies that are currently implemented around the world give us this red line here with, you know, again, pretty large uncertainty. But basically the policies that are in place now keep emissions at about the same level for the rest of the century. If we want to stop at 1.5 or 2 degrees of warming, we need to be on the blue or the green lines and be going down to zero as fast as we can, basically. So yeah, like next, yep. Current policies, like the Secretary General of the UN was saying, are leading us to something like 3 degrees of global warming. And if we're going to be at somewhere manageable, we really need to be looking at stopping emitting all greenhouse gases in the next 25 years, as soon as we possibly can. So finally, after all this gloom, there's a bit of hope. Again, this is a slide from the IPCC, so they provide a bit of hope as well. So, you know, the point is, if we take action on climate change, it'll reduce loss and damage for nature and people. You know, it's a good thing for the world as a whole. And there are all sorts of co-benefits of climate action, a lot to do with, you know, air pollution, a lot of health benefits of taking action on climate change. And what do you know, there are all sorts of effective options already available to reduce greenhouse gas emissions. It's not as though we have to come up with new technologies. We can, so the message here is basically we have the technology and we'd make the world a better place. You know, why would you not do this? I wonder. Anyway, next slide. So where are we going from here? Like I said before, it all comes down to this graph. How high is this spike actually going to get? So we're at, I said 1.3 degrees, you could say 1.4 or 1.2, whatever. A bit above 1 degree above pre-industrial at this level here. So next, so at current emission rates, we'll have enough of this stuff in the air to guarantee 1.5 degrees of warming by the end of this decade, 5 years away. And if we keep going, we'll be at 2 degrees of warming about 20 years from now, 3 degrees of warming 50 years from now, or if we take action and we reduce emissions, now this is starting to be a bit of a big ask, 50% by 2030, that's only 5 years away, but let's imagine we could do it. And we get 100% reduction, that is zero emissions by 2050, that adds up to about the same amount of emissions as just doing nothing for 5 or 10 years. The question is, you know, is that possible? There's no sign that it is. There's a lot of talk about it, but there's been zero action so far. So, what can we do? Well, we can do everything. Click. You know, we are causing this problem. Human activity, that is mostly burning fossil fuels, but also land use change and so on. We're adding stuff to the atmosphere that warms the climate system. We're doing all of this ourselves, so we have all of the power. We can choose to stop whenever we want to. So it's not as though we're just, you know, helpless victims. We are the ones causing the problem. We're harming ourselves. We can choose to stop when we want to stop. So anything that makes a difference, you know, makes a difference. Ride a bike. Wear clothes that last longer. Don't get into fast fashion. Use public transport. Have an EV if you can afford one. Solar panels on the roof of your house. Any way to reduce your energy use, reduce waste, reduce your carbon footprint is a step forward. So, you know, there's all sorts of things we can do. I think one of the most crucial things anyone can do is what I'm doing right now. talk about this problem. We don't really talk about climate change much. It's this huge issue that the whole human society globally is facing, and yet you don't sit at the pub and talk about the situation with climate change. You talk about the rugby or the royal family or whatever, but you don't talk about what's really important, right? Maybe that's just human nature, but it would be great if we all did talk about it a bit more. But, it's not just about individuals talking about to each other or putting in low energy light bulbs. This is a really global problem, and it's a societal problem. So we really need to see governments changing how economies operate, making it easier for people to take the options that we need, the solar panels and the EVs and so on. So helping to steer business and the economy in the right direction, that's a really good thing to be doing. So get active. Help government see what to do. Make a noise. Don't just talk to your neighbours about this, talk to your MP about it. Get a bit of action on the go. And I think it's a global problem. We all need to work together. So cooperate with your own whānau, your workmates, your neighbours. Individual countries can cooperate with each other internationally. The more we work together, the easier it is to fix this problem. And if there's a march on Parliament, like the school strike march just before the COVID lockdowns, where, 20,000 people showed up at Parliament, I think that's me just there. It was a feel-good thing, and that's part of the issue that, if you feel as though you're doing something, if you go on a march, if you do get an EV, if that's your thing, an e-bike or whatever, you feel like you're contributing to go in the right direction, and that's really empowering. It's easy to despair about climate change and think, what can I do? Well, you can actually do a heck of a lot, and just turning up and making a noise at Parliament, I think, is one of the most important things. Okay, so last slide. What do we need? This is what we need. We need decision makers to take it seriously. I've been saying this to people for quite a long time now, and I don't know what it would take for these decision makers to take it seriously. Or to, probably if we had some MPs in the audience, and I'm not sure if we do, they might say, well, I do take it seriously, but then, well, what is the response? What's the action you're taking to reduce the harm, reduce the risk? I just don't see it. There's always more urgent issues to deal with. The economy's always got to be in better shape, etc. And that's just not going to fix the problem. Okay. So basically we need to decarbonise everything as fast as we can. Any way you can find to do that, to reduce emissions, which could be about public transport, it could be about EVs, it could be about changing land use, all sorts of things. We know what we need to do. And we need to support people as we transition into this zero carbon economy. Not everyone can afford an EV or afford to change their lives. So we need to have, that's again where government steps in, to support those who need the support. And I would love to see it become easy to be green. What I mean by this is, if you want to make your carbon footprint zero, which is possible, or maybe, or very close to zero, you can do it. And I know Rod Oram, who died in the last year, he essentially did that. He converted his car to electricity, put the solar panels on the roof, he reduced the family carbon footprint by 95%, I think. But boy, it cost him a lot of money, and it was a big push. You're swimming against the tide doing this stuff at the moment. But what if when you went out, the cheapest car to buy was an EV, because the government subsidised EVs to that extent? What if the bus service was so good you didn't even think about having a car, and all the buses were electric? What if, all the choices that you make in your life about where you live, how you get around, were low carbon, just because that's the way the economy was set up? That would make it easy for all of us to be green. It would make it easy to decarbonise our lives, but it's not where we're quite at yet. So, final points. We really need a shift in thinking here, shift in priorities to get to this point, Policy makers have been well informed on this for decades and nothing has happened. So any good ideas on how to make that change, I would love to hear about it. And the final point, we really need a bit of courage here to take the climate action we need. It's easy to talk about, it's easy for me to talk about it. actually taking the action we need to make the changes we need takes a bit more effort and a bit of courage. Not everybody wants to know about this, and it's going to involve some pain and some expense for some sectors of society, for sure. And it's a natural human thing to shy away from that. So I think a bit of courage to take that action is really what I would love to see from these decision makers. Okay, that's it. Thank you. Any questions?
Start off, James.
Yeah.
I was noticing that in the two European places I've been in Bologna and again in Spain, people are starting to take steps about the system. In Bologna, there was a protest saying, "This is not a random event. This is climate change. What are you doing about it as a government?"
Yeah.
In Spain, they were pelting the Prime Minister with mud.
Yeah, indeed. Indeed, and that kind of protest,
Yeah.
I think it carries weight. Politicians, are there by the grace of the people, so they listen when they get told off. And yes, I was on sabbatical in the last year, and I spent quite a bit of time in Italy, in Bologna, and they have a lot of electric buses there, and the public transport's pretty good, and the trains in Europe is sort of legendary how fast and convenient they are, and a lot of those are electric as well. So, there has been stuff happening in some countries, but that graph of global emissions just keeps on going up. So there's a bit of exporting of emissions. The UK has reduced its emissions significantly in the last 30 years, but there's a lot of argument around, well, they just shipped all the manufacturing off to China and other countries. Maybe that's right. So it's when the collective globally acts to reduce emissions, that's when we'll see some action on the climate system.
Questions? Yes. Hang on a minute. We've got quite a big online audience, so you need a microphone so everybody can hear your question.
All right.
To what extent does sea level rise, or is sea level rise likely to cause earthquakes in New Zealand by increasing the weight on the coastal platform?
Oh, that's a really interesting question, and it on an area that I pretty much know nothing about. I'm not a geologist. I'm not a seismologist. I understand that there's a little bit of evidence that some of these changes and stresses on the crust of the earth through melting ice and glaciers and increasing water in the oceans there's been a suggestion that might have triggered earthquakes, one or two here and there, but I'm not really on top of the literature. And for New Zealand, I just don't know the answer to that question. My understanding is that it is an effect, but it's a relatively minor effect. Now, if there's anyone in the audience who's more expert on this than me, speak up. But as far as I know, it's not a big consideration, at least not in this country.
Other questions?
Oh, over here? Yep.
What's a carbon footprint that would be compatible with 1.5 now for people in this room to aim for or to?
That's a great question. And you've got to think about equity. That a lot of the places that are feeling the effects of climate change most strongly, such as Pacific Island nations, with sea level rise, they've contributed almost nothing to the problem. So, meanwhile, countries like New Zealand, I think the average carbon footprint for a New Zealander is something like 13 or 14 tonnes per year, something along those lines. I think on a global equity basis, I think we should all get to about 4 tonnes per person per year, that sort of order. So it's about 70%, 80% reduction in the average for New Zealand. So it's a big reduction.
And getting to 1.5? Keeping to 1.5?
Now, does that get us to 1.5? Well, 1.5, actually, we have to get to 0 everywhere. So I think that 4 tonnes per person number, where did that even come from? I read about it. That may be compatible with 2 degrees of warming, provided we go from that to 0 before the end of the century. So, ultimately, if we're going to 0 emissions, which is what you need just to stop climate change getting any worse, because until you get to zero, that spike in CO2 keeps getting higher. So just to stabilise, you've got to get to zero emissions. So that would imply that actually the individual carbon footprint has to be zero as well, or as close to zero as you can get it. And another caveat to that, we're talking about net zero. There's a lot of argument about whether planting trees is a good thing overall, but there are so-called sinks of greenhouse gases, such as vegetation and trees. If we can balance the emissions that we can't really get rid of against the parts of the system that are absorbing those emissions, then we get to zero. So maybe individual average emissions, average footprints don't quite have to be zero, but they'd have to be getting pretty close to that. And 1.5 degrees, we're going to be there in 2 or 3 years. It would be an extremely rapid change to see that happen, I think. So I would say we're pretty much guaranteed 1.5 degrees now. We just need to stop as soon as we can, because every 1/10 of a degree warmer, those extremes become more extreme, and so on and so forth.
Yeah, now for the bad news. It looks like Donald Trump is going to be the next US president. Last I heard of the trends that were coming in. And it's pretty clear that he will attempt as much as he can, he and his morons, will attempt to sabotage not only America's contribution, slow movement towards zero carbon, but also much of the rest of the world. And I think my strategy would be to try and distance ourselves politically and culturally as much as possible from Trumpian America. I was wondering what your suggestions might be for a strategy, James.
Yeah, that's an easy question, isn't it? Yeah, look, I've just fired up the New York Times, and it's 210 electoral college votes to Harris, 230 to Trump, so he is in the lead, but it's not quite over yet.
But they're going to lose the Senate and the House.
Yeah, okay. It's not a good news story from the US. I would go back to the idea of cooperation, that all countries have to work together. So rather than distancing ourselves from the US, I'd try and get in there and try and persuade them to change their views. Again, it's an easy thing for someone like me to say. It's a much harder thing to actually do. But I think, ostracising any country, cutting yourself off from other people, is not a way forward. It's a bit like in this country, people who live in the cities saying it's the farmer's problem and the farmer's saying it's the city dweller's problem. That's not helpful. We all need to talk to each other and work out ways to work together. So, what do you do about the situation in the US? I don't have an answer to that. There's all manner of things going on there. But if Trump's government are looking to ramp up fossil fuel production and ramp up emissions, get out of the United Nations Framework Convention and so on, I think New Zealand should work as hard as it can to fight against that in international forums, at the UN, at ASEAN, the EU. Just hold the line against that point of view. I know when Trump was elected the first time around and pulled the US out of the Paris Agreement, a number of other countries just worked a bit harder to reduce their emissions faster to counter that. Having said that, I'm thinking back to that graph of the emissions, they didn't go down. But having that happen in the US may spur other countries to work harder. But certainly we need to work together as much as we can to solve the problem and to counter increases in the issue coming from the US, if that's what's happening. Welcome anyone else's suggestions on that question. Yep.
James, in terms of your experience on the Climate Change Commission, how would you rate the amount of impact that the Climate Change Commission has had on the New Zealand government's position, both the previous government and the current one? It's no secret that I've been pretty critical of the Commission. But I'd be interested in your reflections.
Well, I suppose I feel, and I'm not speaking as a commissioner here, and none of what I said is in my role as a Climate Change Commissioner, but I feel compelled to defend the Commission. They have, in my opinion, acted very effectively under their legislation. They've done what they've been asked to do quite well, I think. How much effect it's had on government? Well, I'd say even the setting up of the Commission and the passing of the zero carbon, that was a big deal from a policy point of view. But I don't see a lot of evidence in agencies of, putting climate change at the forefront of their thinking around any issue, and there's certainly still not a lot of talk between ministers, between governments about what they're doing on climate change. It's just not there. So I think that really the Commission's work has had a lot of impact as yet on government policy. New Zealand's actual emissions have gone down the last few years, and as the Commission pointed out, that was much more luck than good management, and there's no sign that anything's in place to keep that going. So the first emissions budget may well be met. Good luck. But the second and third are probably going to be missed because there's no good management. So yeah, it's been a good experience being involved with the Commission, seeing the work they do. A rather bad experience, the effect on government policy. There's been a few moves of the previous government, but there's no real sign at the moment of any real appropriate effect in government policy from what the Commission's doing, and who knows what the future of the Climate Change Commission actually is. And I will stop being a commissioner in a few weeks, and yeah, we'll see what happens after that. Oh, still down the back, so just hold on. Yeah.
Thanks, James. Really interesting of climate. Any comment on the science of the communication of climate change? Because I feel like, say 5 or so years ago, there was a view that people were into taking it seriously. That hadn't worked, and so there had to be a pivot to a more hopeful message. Yep. The latest discussion I see as a layperson is that that's not working. We need to pivot back to the doom and gloom stuff, which I'll be unconvinced about. This may be outside your purview, but do you have any views on that?
Yeah, I'm aware of all the discussion and the sort of literature around this issue. I think we need a bit of both. People need to understand the problem, and so the first 21 slides were all about the gloom, and then the last 3 slides were the hope, as it were. But people need to understand the scale of the problem and what it is we need to do, but then get the message that we can do it. And I think it's combining those two parts of the story together, in my mind, is a good thing to do. But what's considered to be the best these days, I'm not entirely sure. It's not about presenting people with facts. Basically, what I did tonight is not really the way to get through to people, because it's just scientific information, graphics and numbers and so on. You really need to connect with people, right? You need to get on people's wavelength, understand what their issues are, and if they don't go along with the idea of climate change, understand why that is, what it is, how do they see experts, how do they see scientific information. That's probably more about politics and people's worldviews than it is about the science itself. So I'd say that's a way into those conversations. And I've had a few like that over the years, but yeah, it can be quite hard, People have the views they have because of their life experience, and they've had those views all their life. You can't just step in and say, well, actually, the world's like this, not like that. Most people are resistant to that kind of message, so it's not straightforward. Now we really need a microphone down the front.
One here.
Okay. Thanks very much for a very interesting talk, James. We're talking about persuading the public. I'm interested in what you think about how you can persuade the government. For example, the previous government and the Crown entity that I was on at the time, Kāinora, one of the major things that we had to do was reduce carbon emissions
Right.
in the housing, which meant we built above code.
Yep.
Construction's 20% of carbon emissions. We made sure that they were close to cities, so that was cutting down car use. And then as soon as the government changed, the government said, oh, we can build houses cheaper than that. Your houses are too expensive. And so they cut out all the carbon requirements that the previous government had done. Mm-hmm. So, I mean, that was making solid difference, demonstrable difference, but it made no difference to the government.
Yeah, that sounds to me like the conversation between the economy and the environment, and getting through the idea that the economy is part of the environment, not the other way around, and that, saving money and putting more in the bank so you can afford to take action on climate change is an idea that really needs to be overcome, I would say. And how you do that, I don't know. A lot of people think, the more climate change related disasters we have, the more Cyclone Gabrielles and Dunedin floods and all the rest of it, the more policymakers will take action. And that's a pretty tough approach. The people who suffer from these extreme events probably aren't going to be particularly happy about that. And again, I wouldn't say there's any evidence that there's been plenty of extreme events in recent years, but no obvious effect on government thinking or government policy. So again, I don't know the answer to that question. I would love to know the answer to it, because I've been talking to policymakers and the public for a long time, and I'm pretty sure that most of the people in power understand the problem, but they maybe don't understand the dangers or the possible economic and societal effects. I'm really not sure what the missing link is there, actually.
Just time for a couple more questions. There was one in the front.
Yeah. And there's one back over there too.
Thank you very much, James. Stand up, am I?
Oh,
no, don't
yeah,
need to.
Over to you.
Great. Just, I guess, picking up on just what you were saying there about that, why is nobody taking it seriously? It seems to me, and I think to quite a few other people, that the real elephant in the room is growth, which is we are hitched to growth, we're hitched to capitalism, and so long as that system is driving us along, it's very, very difficult. I mean, degrowth, there's a lot of degrowth manifestos out there about, I wouldn't like to be in charge of managing it, I tell you that, but I think until such time as we look that one square in the face and, say it's got to be, we've got to just wind our production, our consumption, our lifestyles back, what people say, something like about 1970. The way we lived in 1965 or 1970, if we could get back to that sort of... It's very, very hard to make it happen, but I think until such time as we look at our own political economy and the global political economy, which is hyper-capitalistic now, hyper, it's going to be very hard to address climate change.
Yeah, thank you, and it's not something I even touched on in the talk, but you're quite right. Growth in anything on a finite planet has to stop sometime. So how much longer are we going to let it continue? That's the real question. So I'm very sympathetic to ideas around things like degrowth and just changing the economic paradigm away from constantly increasing GDP, because that is exactly what's driving us down the tubes. So again, how we do that, it's easy to talk about in a setting like this, but getting change happening on the ground, I don't know, do we start at home, could local communities set up some sort of degrowth paradigm and show other communities how it's done and could grow from there? I don't know. I honestly, again, I'm saying I don't know a lot to these questions, but yeah, you're quite right. And I think Naomi Klein was the person who said in one of her books, about the time that we really started getting a handle on how the climate was changing in the 1980s, was right at the time when neoliberalism came along, and that sort of stymied the action on climate change and took over the conversation. And that conversation is still overtaken by just an economic lens on everything. what we just heard about, well, we're building these houses with all these nice low carbon features, but they're more expensive, so we'll just scrap all that to save a bit of money, and that's such short-term thinking. It's it's sad. Anyway, now the lady down in the back there, she's been waiting a while. I mean, there are others, but
truthfully, not particularly a question, statement. It's just, I read a paper sent to me by a friend who's a psychologist, and she belongs to Psychologists for Climate Change Progress. And a big global survey, back to your question about psychology, Max, big global survey showing that many people know that action is desperately needed, but the thing that holds them back is not believing that others will act. It's a type of perverse fearfulness about, I'm not going to do anything because other people aren't going to do anything, when I know I really have to do something. That there's something in that trap there which has been quite well documented in psychological literature. But anyway, the statement is that we've got the emissions reduction plan being dumped on us at the end of this year, and that is the point when everybody needs to make a lot of noise. That is the critical point. Influenced by ACT in New Zealand First, is going to make a completely disgusting mess about it. And that is where we need a lot of noise, and we need to get collaborative about making that noise, and it needs to be everywhere, and it needs to be very loud, just at the end of the year.
all right, thank you. And just reminds me, I think one of the most useful things the Climate Change Commission does, and they started doing that this year, is their monitoring role. They prepare a document which they hand to government to say, well, how well are you doing on emissions reductions? How well are you doing on adaptation? Well, actually not very well at all. And that's a public document that hopefully will fire a bit of public response. And it's that public response that drives political behaviour, at least I hope so.
Okay.
Didn't the last government actually go short on the climate change recommendations?
Which ones?
The last government did not follow the advice of the Climate Change Commission on ETS settings, and actually had to go to court.
Yeah, that's true. That's true. So, nobody's been squeaky clean on this at all.
Pressure from business.
Oh, yeah, sure. That's right. I mean, if you could consider climate change in isolation, well, maybe there'd be action. But of course, all these other considerations come into play, and all the vested interests have the ear of policymakers. So
It's probably a good place to end on.
We've
run out of time. So could you join me in thanking James for a good session?
Thank you.